Assalamualaikum. Welcome all. I am going to explain to you the pipe friction experiment. Okay. So before we go to the setup, just I will brief you about the experiment and a little bit of calculation. So pipe friction experiment, if you see water or any fluid is flowing in a pipe, and then you expect that the pressure will be lost as it travels along length of pipe. So point 1 and point 2, if you connect manometer, you will see it will raise the height. P1 equals rho GH1 and P2 rho GH2, and you can see here we expect that H2 will be less than H1. So this is called head loss. H1 minus H2 is your head loss, which happens because of friction in pipe. So this is the job for you to measure the head loss or pressure loss due to friction in a pipe at different flow rate. So you will have a manometer connected between 2 points. You measure H1 and you measure H2 at different flow rate. We have a rotameter to measure the flow rate in LPM, liter per minute. So you increase the valve, open the valve and get different flow rates and measure H1 and H2. So this will be your measured data, experimental data. Delta P measured or experimental is rho G H1 minus H2. Okay. So this is measured. Now your job is to compare the experimental data with the calculated data. Okay. So how you are going to do that? For each measurement you have the flow rate. Okay. So you get the velocity how? By dividing flow rate with area. Area of the pipe, diameter of the pipe is given to you. So once you know the velocity, you can calculate the Reynolds number. Okay. And once you know the Reynolds number, you know the region of your flow, where you are in laminar, where you are in turbulent flow or very high turbulent flow, and so on. So now, depending on the value of Reynolds number, you will search a suitable correlation which relates friction factor F with the Reynolds number. So this is your job to search little bit, see the textbook, see literature, which will fit your experimental data to find F. So once you find F, that is friction factor, and it is defined as, this is fanning friction factor, defined as delta P divided by 2 rho V squared d over L. So once you know the value of F, everything is known to you, you can get the delta P, and that will be delta P calculated. So for each data, you calculate the delta P and compare with the measured value, and you can try to get the error and so on. Okay. And for the next job is to see how delta P is affected when we change the flow rate. So as we expect, when we increase the flow rate Q, delta P will increase because we will have more friction. And the most important thing, we want to know what is the relation between delta P and Q, so plot all data points with a scattered line, a scattered point, and try to connect and search in literature what is the relation between delta P and Q. So in your experiment, mostly you will have turbulent flow. So look for how delta P depends on Q. So I will give you the hint, it is like Q power n. So if you have data, you can fit a power train line and see what is the power in Excel you get, Q power n, and you will get around 2, 1.9, 1.8 or 2.2, something like that. So that gives you the idea how delta P varies with flow rate in turbulent region. For laminar, we have exact equation which says that delta P is linear with flow rate. Okay, that's it. We'll go to the setup now. Thank you. Welcome back. So I'm going to show you how to conduct a pipe friction experiment. You can see this is our setup. We have pipe network, different pipe diameters. So right now we have connected the manometer across this pipe. Okay, this is a smooth bore pipe, and you can see I will start the pump, and you can see the flow is blocked all over. Valve is closed, closed, closed. So this one is open only, and from this valve we control the flow. So right now this is also closed, so there is no flow right now, and you can see the manometer level is same. So there is no flow, there is no pressure drop. Okay, so now I can open the valve little bit, and you can read the flow rate using this flow meter. Okay, and now you see this one is the P1. Water is flowing like this. So this is P1, this is P2. What we expect, P1 will rise to rho g H1, and this one H2. So you can see here, if I follow here, this is more than this. So this is your H1 minus H2, the head loss which is occurring between this point and this point. Okay, and this loss is because of friction. So you measure at different flow rate, H1 minus H2, and you get the data. Just open a little bit more, and you will see that the difference between H1 and H2 is getting more. So as we increase the flow rate, we will have more pressure drop, and you will plot in Excel and get the data and model and equations how exactly they are related. So this is the way to do the experiment, and we can connect to a smaller diameter or bigger diameter to see the effect of diameter on pressure drop. And you can see the length are constant. So length, we will fix the length, and we can change the pipe diameter to see the effect on pressure drop with diameter of the pipe. So you have the data with you, and you can start calculating the delta P experimental and then delta P calculated using the friction factor I have explained to you. Okay, that's it. Thank you very much.